Today's notes are C2 and they look at quadratic equations. So we start out with a reminder about a couple definitions. So the vertex of a quadratic function is the minimum or maximum point on the graph, and the axis of symmetry is the vertical line that divides the graph in half. You want to remember that the axis of symmetry is a vertical line, and so it's always going to be written in the form x equals. So here in this first example, we're given a graph and we're asked to identify the vertex, determine whether the vertex represents the maximum or minimum point on that graph, and then also give the domain and the range. So remember, the vertex is the turnaround point on the graph. For the first graph here for A, the vertex is at the point 3, -1. That vertex represents a minimum value on the graph because the graph goes no lower than the vertex. When we talk about domain and range, there's a couple different ways that we can write it down. The domain is all real numbers, and so one way that that can be written is like this. So the domain is all values from -infinity to +infinity. The range for this graph is all of the values that are greater than or equal to the minimum. And so for this one, for the range, we can say that it's all values starting at -1, including -1, and then going upward from there, so upward to +infinity. On B, the vertex of the graph is at the point 1, 5. On this graph, that point represents a maximum value because it's the highest point that's on the graph. On this one, my domain is still all real numbers, so it's everything from -infinity to +infinity. There's no restrictions on the domain. My range is all of the numbers that are less than or equal to +5. So starting with -infinity, it's everything up till and including +5, but then nothing greater than +5. In the next example, I'm asked to determine if the quadratic function has a maximum or a minimum value. Notice that the leading coefficient 2 is negative, and so this graph will have a maximum value. That negative out front means the graph is opening downward, and then we're asked to find that maximum or minimum value. With any quadratic function, x equals -b over 2a allows you to find the x value of the vertex, and then from there, you can plug that value for x back in for y, and that'll help you find the maximum value. So my b is +12, and my a is -2. See, -12 divided by -4 gives me 3. And so the x value of my vertex would be 3. Now to find the maximum value, I'm going to take x equals 3 and I'll plug it into the equation for x. So everywhere that I see an x, I'll replace it with that x value, and then I'll use PEMDAS to simplify. So 3 squared gives me 9, -2 times 9 gives me -18, and then 12 times 3 gave me 36. -18 plus 36 gives me +18, and then 18 take away 10 gives me 8. The maximum value of this graph is at 8. Remember, when you give a maximum or a minimum value, it's the y value of the vertex that you provide as your answer for the question. On the next example, I'm asked to find the axis of symmetry, the vertex, and the y-intercept, and then create a graph for the function. And so for this one, I'll start out the same way. So x equals -b over 2a. My b is +2. My a is -1. And -2 divided by -2 gives me +1. And so for this one, my axis of symmetry is the vertical line x equals +1. The axis of symmetry is generally represented by a dashed line, and so I can add that dashed line onto my graph. So my graph will be symmetric about that line. That line's going to go through the middle of my graph. The next thing I need to do to find the vertex is I need to plug in x equals 1 into the equation and solve for y. And so I'm going to carefully plug it in everywhere that I see an x. Then I'll simplify using PEMDAS. So 1 squared is 1, but then it remains negative because of the negative out front, and 2 times 1 is 2. And then from there, I'll keep simplifying. 1 plus 3 will give me 4. And so the vertex for this graph is at the point 1, 4, and I can also add that onto my graph. So on my graph here, that's going to be my turnaround point. The y-intercept of a graph is the point that the graph crosses the y-axis. You can determine that by plugging in a 0 for x. And so looking at the work for this one, 0 squared would give you 0, 2 times 0 would give you 0, and then 0 plus 3 would give you 3. You can also remember that the y-intercept is always going to equal the c value of your graph. So here my y-intercept is going to be at the point 0, 3. So that's the point where the graph will cross the y-axis. To graph the rest of this graph, it could be helpful to make a table. Remember, the vertex goes in the middle, and then you can pick 2 points that are smaller than the vertex, and you can pick 2 points that are larger than the vertex. Quadratic equations are symmetric, and so the numbers that are in these places are going to be equal to each other. We already know that 0 goes with 3, so that means that 2 will also go with 3. Here will be a point on the graph. And then I can plug in either my -1 or I can plug in my 3, and when I plug those in, similarly to how I found the y-intercept, I'll get 0 for both of those, and so that gives me the shape of my parabola. These can be kind of tricky to draw. You want to try to draw a smooth curve that goes through all the points, and then you would include arrows on both sides to indicate that the graph continues. All right, on the next example, you're asked to identify the vertex, and so to do that, I'll start with x equals -b over 2a. Your b is -4, so it's -4 over 2 times 1. Negative here turns into a positive, so I'm going to get +4 divided by 2, and so I'll get x equals 2. I'm finding the vertex though, so now I need to plug that number in, and I'll plug it in everywhere I see an x. 2 squared will give me 4. Negative 4 times 2 will give me negative 8. And then I'll continue to simplify by combining like terms. So here I'll get y equals negative 1. And so my vertex for this graph is at the point 2 comma negative 1. The next question wants me to identify just the y-intercept. So remember, to find a y-intercept, you're going to plug a 0 in for x. 0 squared is 0. 0 times 2 is 0. 9 times 0 is 0. And then negative 16. And so when you combine like terms here, you'll get negative 16. So for this one, your y-intercept is at the point 0 comma negative 16. Remember, your y-intercept is always going to be equal to the c value. The last example on this page wants you to order the graphs from widest to narrowest. And so to do this, we're going to compare their a terms. So we're looking at the numbers that are out front. Out of the numbers 1/3, 3, and 1/6, 3 is the largest number. And so because 3 is the largest number, it means that that graph is going to be the narrowest. Out of those three a values, the number 1/6 is the smallest number, which means that out of the three graphs, that graph would be the widest. You're asked to order them from widest to narrowest. And so h of x would be the widest graph because it goes up the most slowly. F of x would go in the middle because that a value is in between the other two a values. And then g of x would go last because that graph has the largest a value, and so that's going to stretch that graph up faster. So out of the three graphs, that graph would be the narrowest. So for the purpose of answering the question, it would be h of x, and then f of x, and then g of x. Make a note here that a stretch of a graph is something that's called a dilation, which is a non-rigid transformation. In a dilation, the graph isn't just being shifted around or flipped. In a dilation, the graph is actually being stretched or compressed. And so a dilation is considered a non-rigid transformation because the graph ends up having a new shape compared to when it started. On this next word problem, it says a punter kicked a football into the air. We assume it started on the ground with an upward velocity of 64 feet per second. Its height h of t in feet is given by the equation. And so we want to start out by finding the vertex. So your a is negative 16. Your b is positive 64, and then your c is omitted. So remember, that means your c is 0. To find the vertex, I'm going to do x equals negative b over 2a. So negative of positive 64 over 2 times negative 16. That's going to give me negative 64 divided by negative 32, which will equal positive 2. So x equals positive 2 will be the x value of my vertex. To find the y value of my vertex, I'm going to take x equals 2, and I'll plug it in wherever I see a t, wherever I see an input. So I'll plug in the 2, and then I'll follow PEMDAS to simplify. So negative 64 plus 128 gives me positive 64. And so my vertex for this graph will be at the point 2 comma 64. Remember, to find the y-intercept, you can plug a 0 in for x, or in this case, the variable is t. And so 0 plus 0 will give me 0. And so the y-intercept for this graph is going to be at the point 0 comma 0. The next thing I'm asked to do is I'm asked to graph the function. So it starts at 0 comma 0. Its vertex occurs at the point 2 comma 64. And then from there, we can apply the fact that we know that the axis of symmetry divides the graph in half. So if it's going up and getting to the vertex in 2, it'll be back down to the ground in 4. Remember, these points will get connected in a smooth curve, and then we're going to use the graph to answer some questions that follow. The first question asks, what was the starting height of the football? And so based off of the y-intercept being at 0 comma 0, we say that the starting height of the football was 0 feet. It takes the football 2 seconds to reach its maximum height, and the maximum height that the football reaches is 64 feet. That's the highest that it goes. The last question says, when does the ball hit the ground? And so that occurs 2 seconds after that axis of symmetry. And so the ball will hit the ground after 4 seconds. So on this one, it says that an arrow shot upward from the top of a tower. So it starts at 144 feet. It's not starting on the ground, so it's different than the last problem we just did. It's modeled by this equation, and we're being asked to determine the number of seconds it takes for the arrow to hit the ground. The arrow hitting the ground would represent one of the x-intercepts of this question. And so I'm trying to figure out when the function equals 0, so I can solve this by factoring. On this question, I can hockey stick out a negative 16 because all three of those numbers are divisible by 16. And so when I divide that out, I'll be left over with t squared minus 8t minus 9. I'll t-chart what's left over. Two numbers that times to give me negative 9 that add to give me negative 8 are the numbers negative 9 and positive 1. And then I'll use the zero product property and solve this to find the x-intercepts. And so when I do that, I'll get t equals 9 and t equals negative 1. Negative 1 doesn't represent the x-intercept that I'm looking for. T equals 9 means that after 9 seconds, I'll have an x-intercept. And so after 9 seconds, the arrow that starts out at 144 feet goes upward and then comes back downwards. After 9 seconds, it would hit the ground. All right, up next is a reminder that solutions to a quadratic equation, just like we saw in the problem above, are the values of x that you get when you set the equation equal to 0. And so these are the same as x-intercepts. Sometimes they're called roots of the graph of the function. And so here in the picture, we can see that there are two x-intercepts, and those two x-intercepts appear to be at the points 2 comma 0 and 4 comma 0. Sometimes instead of it being written like this, you'll see it written as x equals 2 and x equals 4 or x equals 2 comma 4, just so you know those are the same. So when you're solving quadratic equations, there's a couple of different ways that you can solve them. So the square root method, factoring, completing the square, and the quadratic formula. In the next example, I'll do one example of each. All right, so in this first one, I'm being asked to solve each quadratic equation. So I'm trying to figure out the number or numbers for x that would make this be true, that would make this equation equal 0. Notice that on this one, it does not have a b term, and so that means that I can solve it by the square root method. I'll start by adding the 45 to both sides, then I'll divide both sides by 5, and lastly, I'll finish by taking the square root of both sides. And so for this first problem, the answer that I'll get is x is equal to plus or minus 3. Those are the two zeros of the function. If I solved this by factoring or by the quadratic formula, I would get the same answer to the question. On B, this equation is factorable. The 11's on the wrong side though, so I'm going to start by moving the 11 over. I'll subtract the 11 from both sides. X squared plus 10x minus 11 does not have a GCF, so there's nothing to hockey stick out, which means I'll t-chart it. So two numbers that times to give me negative 11 that add to give me positive 10 are the numbers positive 11 and negative 1. Once I have factored it, then I can use the zero product property to solve to find the two values for x that make this equation equal 0. So I'll set each of the factors equal to 0, and then I'll solve both of them for x. And so the second equation has two solutions, x equals negative 11 and x equals positive 1. Example B that I solved here by factoring, if I solved it by the quadratic formula or if I solved it by completing the square, I would get the same answer to the question. On example C, my b term is an even number, and so I'll solve this one by completing the square just for the sake of an example. You want the 7 to be on its own side of the equal sign. And so the first thing that you'll do here with completing the square is you'll create the blank space. Remember, to complete the square, you take half of your b term. This is your b term right here. So you're going to take half of that, so negative 1, and then you square it. So negative 1 squared is positive 1, and that becomes the value that you add to both sides of the equation. And then on the right-hand side, I'll combine like terms, and now I'm trying to solve to get p by itself. So here I'm going to take the square root of both sides. Don't forget the plus or minus on the square root of 8. The square root of 8 can simplify further because the square root of 8 is the square root of 2 times the square root of 4, but the square root of 4 can come out as a 2. So I'll have p minus 1 is equal to plus or minus 2 square root 2 once I simplify that radical. And then the last thing I need to do to get the p all by itself is I need to add the 1 to both sides. So for this one, I'm going to get p is equal to 1 plus or minus 2 square root 2. This equation is not factorable. If I had solved it by the quadratic formula, I would have gotten the same answer to the question. Oh, and then this one's supposed to say D. So in this last example, I keep mentioning the quadratic formula. I haven't done a quadratic formula example yet. I could solve this one by completing the square, but I'll solve this one by the quadratic formula. A reminder, so the quadratic formula is this formula that's here given, and then I'll plug the values in. So my B is negative 4, my A is 1, and my C is negative 2, and then my A is 1. Negative 4 on the outside makes a positive 4, and then I'll simplify what's inside the square root. So negative 4 squared is positive 16, and then negative 4 times negative 2 is positive 8. 2 times 1 gives me 2. 16 plus 8 gives me 24 inside the square root, but then here the square root of 24 can simplify further. The square root of 24 is the square root of 6 times the square root of 4, but the square root of 4 can come out as a 2. So the last thing I need to do to finish simplifying on this one is to recognize that the coefficients can simplify. So here and here, both of these values in the numerator can divide by the denominator. And so as an answer for this question, I'm going to get D is equal to 2 plus or minus the square root of 6. And so 4 divided by 2 gives me 2, and then 2 divided by 2 gives me 1. So my answer for this one is going to be D equals 2 plus or minus the square root of 6. If you solved this one by completing the square, you would get the same answer to the question. All right, the next set of examples has definitions of vertex form and intercept form. In vertex form, you can pick out the vertex. It's at the point h comma k, so it's the opposite of the number that's on the inside and then the same as the number that's on the outside. When an equation is written in intercept form, it looks like this. And so an equation in intercept form, it's very straightforward to state the intercept because the intercepts of the function are just the opposite of the terms that you see on the inside. So in the first example, it says what is the vertex of the function, and the function is given to you in vertex form. And so the vertex of this function is going to be at the opposite of the number that you see on the inside and then the same of the number that you see on the outside. So the vertex of this function would be located at the point negative 1 comma 5. In the next example, it says what is the equation of a quadratic function? We're assuming the parent function is y equals x squared that has gone 2 units to the left and then 3 units up. If the quadratic function is shifting in that direction, that means that the vertex is also shifting in that direction. So 2 units to the left would be an x plus 2 on the inside, because remember inside is opposite, and then 3 units up would be a plus 3 on the outside because the outside number is the same. And so this equation can stay written in vertex form. So x minus 2 quantity squared plus 3 would move the function 2 units to the left and then 3 units up. In the next example, it's given to you in intercept form and you're being asked to figure out the x-intercepts. So I'll set each of these equal to 0, and I'll use the zero product property to solve. And so there would be two x-intercepts of this function. They would be located at the points 2, 0 and 4, 0. The next example wants us to write the equation that has x-intercepts at -4, 0 and 5, 0. So you want to work backwards based off what we did in the last question. So y equals, if it has an x-intercept at -4, that means that one of the factors would have to be x plus 4. And then if it has an x-intercept at +5, it means that one of the factors would have to be x minus 5. And so the equation written in intercept form would be x plus 4 times x minus 5. All right, in the last example on the notes today, you are given the graph of a quadratic function. You can see on the graph that the vertex is right here at the point -2, 4. And you can also identify the two x-intercepts. So this graph has an x-intercept at 0, and it also has an x-intercept at -4. You can use those pieces of information to write the equation both in vertex form and to write the equation in intercept form. So this function has shifted 2 units to the left. It's gone up 4 units. And it's flipped upside down, so it's reflected from the parent function. The negative out front causes the reflection. X plus 2 on the inside moves the vertex 2 to the left, and then plus 4 on the outside moves the vertex up 4. And so in vertex form, it would be y equals negative x plus 2 quantity squared plus 4. Written in intercept form, I still need the negative out front for the reflection. This graph has an x-intercept at -4, so it's going to have an x plus 4. And then the other x-intercept is at 0, and so I'm going to write it here as x plus 0, but then I want you to fix this on your papers because it wouldn't look like that. The plus 0 part would be irrelevant to the question. And so the way that you would most commonly see this answer written is the negative would still go out front, the x would go out front, you drop the plus 0 part, and then the x plus 4 would go second. And so written in intercept form, this one's going to be y equals negative x parentheses x plus 4.